Digitalization is transforming the way we produce, distribute, and consume energy. It also offers powerful tools to improve energy efficiency. It is not only a technological shift, it is a concrete opportunity to reduce waste, optimize consumption, and improve quality of life. We will illustrate the efficiency potential of digital technologies in 4 key sectors: buildings, industry, transport, and energy. Buildings, which consume about 30% of global energy, account for more than 20% of greenhouse gas emissions. In this sector, sensors, smart appliances, and especially energy management systems can significantly increase energy efficiency. Smart sensors detect temperature, humidity, and occupancy in real time. Energy management systems automatically regulate heating, ventilation, and lighting to minimize energy use. But that's not all. Digital technologies also offer highly innovative approaches, such as the use of virtual models, so-called digital twins. These virtual models make it possible to simulate the operation of buildings with unprecedented accuracy and thus identify solutions to optimize the use of resources and energy. But what is the potential of digital technologies in production processes and industrial sectors? Industry consumes 1/4 of European energy, and at the global level is responsible for about 34% of greenhouse gas emissions. Thanks to digital technologies, this sector is evolving toward so-called Industry 4.0, characterized by connected machinery, real-time data, and intelligent algorithms. Some industrial sectors require large amounts of energy for their production processes, but control and energy management systems increase energy efficiency. In aluminum production, for example, they can reduce electricity consumption by 7 to 10% per ton of output. The use of sensors and machine learning techniques enables predictive maintenance. Instead of replacing machinery periodically, replacement occurs when data indicate deterioration. This reduces downtime and can increase efficiency by up to 15%. In addition, digital technologies make it possible to optimize supply chains. Enterprise resource planning systems are software tools that automate business processes and integrate the management of production inputs, suppliers, and sales. They provide a unified view of operations and reduce the waste of resources and energy. Digital technologies also have significant efficiency potential in the transport sector, which consumes more than 30% of European energy, and at the global level is responsible for about 15% of greenhouse gas emissions. Cities, for example, can use intelligent algorithms to regulate traffic lights and redirect flows. Where this has been implemented, traffic has been reduced by up to 30%, reducing also fuel consumption. Car sharing lowers the number of vehicles required and energy use. GPS, sensors, and algorithms make it possible to optimize every movement, from freight logistics to urban mobility, saving millions of liters of fuel each year. Finally, digital technologies can increase the efficiency of the energy sector itself, as illustrated by the case of smart grids. In a traditional power system, energy flows in a single direction. In a smart grid, by contrast, everything is interconnected: producers, users, and storage systems. This makes it possible to effectively manage the variability of renewable energy sources and to implement demand-side management strategies, known as demand response approaches. Thanks to information from smart meters, households can avoid waste, reducing their energy demand by up to 10%. But that's not all. Digital technologies make it possible to operate appliances remotely based on energy production, for example, self-generated by a solar panel. This reduces costs and lowers emissions. The information collected through digital technologies does not only increase energy efficiency, but also institutional efficiency. These data feed predictive models and open-source platforms, providing the basis to improving decision-making processes. However, efficiency can stimulate more intensive use of a technology, partially or fully offsetting expected energy savings through so-called rebound effects. A clear example of this is video streaming. Data compression and faster networks have made it possible to watch high-definition content using less bandwidth per stream. Instead of settling for the savings, consumers have started to watch more and more content on increasingly larger screens. The result is that video traffic has surged. In 2018, video streaming accounted for 60% of global internet traffic. It is estimated that online video viewing generates an annual amount of carbon dioxide emissions comparable to those of a country like Spain. A similar phenomenon can be seen with cloud computing. Users store thousands of photos in the cloud, thanks to nearly unlimited storage capacity at accessible costs. However, every gigabyte stored requires energy and generates emissions. So let's summarize what we've discussed in this lecture. Digital technologies are important levers available to firms, citizens, and policymakers to increase energy efficiency and achieve emission reduction goals. However, this positive narrative must be complemented by a more careful analysis of rebound effects and how they can stimulate energy demand. For digital technologies to truly serve sustainability, a solid governance framework is necessary. Understanding how to achieve this is a key research question for many scholars and policymakers. However, we cannot only focus on the relationship between digitalization and energy. We must broaden our perspective to the dynamics linking the economy, society, and digitalization. These are precisely the topics we will address in the next lectures.